This question is from GATE 2017. This is from Theory of Computation. The question is, we have two grammars. These grammars are context-free grammars, and this grammar is defined over the alphabet set ABC. Now the question is, they are asking about the intersection of these two languages. That means the languages obtained using this grammar and the language that is obtained using this grammar. We are talking about the intersection of those two languages, and we have four options. We have to decide which one is true. There are several approaches to solve this question. First one is, you may want to find out the languages first, then you may find out the intersection of it, but we have other approaches also. Let's see. See, in case of G1, what we are getting is, we have two productions, S and T. S and T are non-terminals, and from the first production we are getting A as B, but from G2 we are getting B as B, B as A. So if you want to find out the intersection, then A as B and B as A should not have any common part, right? Because it is starting with A and it is starting with B. It will generate the same number of A and B's, but there are no common parts. So this intersection part will become 0. So the only thing we have is S derives T, and T derives Ct and epsilon, right? And from G2 we are having S derives T and T derives Ct and epsilon. Now this is the common part. So this derivation and this derivation are nothing but the grammars for C closer, right? Where C is a non-terminal symbol. I'm sorry, C is a terminal symbol. So these two grammars are generating C closer. Now C closer means it's a regular language, definitely, but this is not finite. We can generate any number of C's from this derivation. Now the correct option should be, it is non-finite but regular, right? Because C closer means the number of C's will be infinite, but this is a regular expression. I mean, it's a regular language, so you can generate any number of C's. That is why it's a non-finite and it's a regular. So the correct option is option B. Now you can solve it in other ways also. You may want to find out the language that is generated by this grammar. So what is LG1? LG1 is nothing but, see, this is nothing but A closer and B closer, right? So this is nothing but A to the power n and B to the power n, right? That why? Because it, from this derivation we are getting the same number of A's and B's. That is why it should be A to the power n and B to the power n, and in place of S we may replace it with T. That is why we can get this derivation. So if I replace S with T and then I substitute T with Ct, then we should get C closer here, where n should be greater than equal to 1, because n cannot be it cannot be 0. Okay, let me check it. Yeah, it can be 0 also, right? Because we can directly replace S with T, then we should get just C closer, so it may be 0. So this is the language that is generated by LG1. Now in case of LG2 we are getting the same thing, but B should come before A, that is C closer and A to the power n, where n is greater than equal to 0. Now if you observe these two languages, these things are not common. The only common part is, that is, if you find the intersection of it, LG1 intersection LG2, you should get C closer only, right? So you may take different approaches, but the answer will be C, closer. And in case of GATE or this kind of competitive exams, you must think about the time also. So whatever approach you may take, that should be time saving, and you should be comfortable in that. So please make a note of it, and you may take this approach also. This is also fine if you are comfortable with it. So the correct option is option B.